everybody, welcome back to Silver Octagon Technologies, and in this video I'm going to be demonstrating my newest project, which is a freight handler droid, aka an autonomous tracked vehicle. So to begin, I want to talk about some of its features, and let's begin with the tracks. So each individual track I designed, and they're caterpillar tracks. So it's nothing too fancy, there's no suspension, but there's 36 tracks altogether on either side. And it has two 200 RPM motors driving either side. I don't know if you can see on the inside there, but I have a gear meeting another gear to create enough torque to pull these tracks. I had a lot of trouble designing the sprockets because this is my first time building like a robotic tracked vehicle, or actually finishing a robot for that matter. So this was technically my first finished robot. Now SD1, I am still working on SD1 and I plan to make future videos very soon. And the reason why I haven't posted in so long is because I am now in my college living quarters. So, alright, back to it. So, let's check out the back. So this is the programming port and the power port for the Arduino. This is kind of like an open space where I left all this to where I can do that. And if you look on the bottom, I have a 9-volt battery powering the Arduino, and on the inside, which I'm going to open up in a second, has an 11.5 volt battery controlling or powering the control system, which is an L298N module for the motors and an Arduino, as well as it powers these LEDs. And when the robot backs up, the LEDs turn red, and when it's on, this yellow light and this blue light indicators turn on. So let's open it up. So it's not the prettiest internals for electronics housing, but it works. Everything works, and I'm pretty satisfied with this robot. So far I've programmed it to go forward. It drops its forks, which I'll get to that later. It drops its forks, and then it turns. I think it backs up first. It's been a while since I messed with it, so it'll back up, and then it'll do 180, and then repeat the process and turn the opposite direction. And yeah. So now I'll demonstrate for you guys and show you exactly what it looks like. Before I demonstrate, I want to talk about the forks. Okay, so it's driven by this this servo, which is powered by the 9-volt battery along with the Arduino. It's not enough power for it, honestly, but it does the job. It's a simple linkage design, excuse me, and it does its job. So what it's supposed to do in my future plans for it is it's going to lift up like a small box, or like I should say a pallet, similar to like a freight handler or a forklift. There we go. So essentially that's its name. So it stands for, I don't know if you can see that. Let's see. So it's FHD1. So it's Freight Handler Droid 1. Alright, now let's demonstrate. So now the program is running, but the motors are not on yet, which is this switch up here. So it'll run through its cycle, lift and dropping the forks, and in order for it to run properly, I actually have to turn the motors on first and then the program. So let's go ahead and do that now. So it appears that my battery is dead. It must have turned on in the car ride. The switch is easily messed with. So let's go ahead and try to change the battery and see what we can do. So this should make interesting content. So my battery was dead, and now I am receiving power, as you can see. Inside, the red light is on. So that means the motors are on. Now let's go ahead and do a test demonstration. And there we go. So it's on a fixed program and it will continue this forever. I still have a couple of bugs to work out, but nonetheless it works. There's a lot I need to change. Its turn radius on one motor is actually good, but it's this one that is not. There it goes. I hope you enjoyed this video. Don't forget to leave a like, subscribe if you haven't, and see you guys next time.